Confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm. Thank you. Yes, Vishal. Wherever you have the Deccan Trap, you have the presence of black soil. The basaltic rocks, when they disintegrate to form that soil, or when they weather down to form a soil, it leads to the formation of black soil. Pooja, what is the issue? Kindly highlight. Whichever issue that you are facing as of now for the recorded videos, I would advise you take a screenshot, send a mail to us at IS Live, and we'll get the resolution done as soon as possible. Okay. So, hello, a good afternoon to all of you, and welcome to another session, post lunch session. And I hope that you have had a healthy meal, but not healthy enough or not hearty enough to put you to sleep. So, here till now, we have covered the portion of the aspects of, let's say, the physiography in terms of the northern plains, the desert areas. We had taken a look at the peninsular plateau, its formation, the aspect of the Ghat section also we have studied. And now we will come to the portion of the coastal plains as well as the islands and their formation. Okay. Roshan, screenshot is not okay. Take a pic, take an image. Let's say if you are opening it on any of your screens, take an image from somewhere else and you can send it to us. There's always a solution, my dear friend. So, here, basically, we had taken a look at the formation of the Ghat sections. So, here, when we talk about the Eastern Ghats are particularly discontinuous. And they are discontinuous because they have been weathered down. They have been weathered down by the movement of the rivers, by the movement of the various streams. There has been significant amount of erosion carried out across the Eastern Ghats. And why is that? Because the slope of the land is from west to east. The general slope of the land in the peninsular plateau is from west to east. So majority of the rivers, even if they originate and when they originate very close to the Western Ghats, rather than draining into the Arabian Sea, they end up flowing all the way to the eastern side and they end up draining into the region of Bay of Bengal. So here, that is why erosion and weathering has been carried out at an exaggerated rate across the Eastern Ghats. So here, they are eroded and cut through by the four major rivers of the peninsular India that you have: Mahanadi, Godavari, Krishna, and Kaveri. Now, important ranges in the Eastern Ghats. Eastern Ghats also are made up of many small ranges. So you have the Javadi Hills, the Palakonda Range, Nalamalla Hills, Mahendragiri Hills, you have Chevroy. All of these, they end up making the and constituting the portion of Eastern Ghats. Now here, Eastern and the Western Ghats, they meet each other in the southern tip and southern portion, that is in the region of the Nilgiris. Now, UPSC had asked a question about this in the prelims of 2017. Now, the question which UPSC had asked was that in how many states do we have the presence of Western Ghats? So, what do you think is the answer? If I ask you that in how many states we have the presence of Western Ghats, what is going to be the answer for that? Let me know. Think about it and let me know that in how many states we have the presence of Western Ghats. Very good, Ajit and Pranay. So, when we talk about Western Ghats, it extends right from the region of southern Gujarat. Then, after that, comes Maharashtra. Then, after that, comes Goa. Then after that comes Karnataka. Then after that comes Kerala. Then after that comes what? After that, you have Tamil Nadu. So how many states are there? 6. Okay. So these kinds of questions are asked from this portion of physiography. So when you are taking a look at the physiographic division, see, you cannot predict the question which will come, because UPSC finds very innovative methods. Even in the portion of mapping, for example, UPSC in the same year, 2017, had asked a question that if you travel from Kohima to Kottayam, Kohima in the region of Nagaland all the way to Kottayam in Kerala, what are the minimum number of states that you have to cover? So what that led to is that all the students, they started learning weird facts, that if I have to move from Jalandhar to Chennai, how many minimum number of states? If I have to move from Ladakh to, let's say, Gujarat, how many minimum states? So that is not the solution. That is not how you proceed with preparation. When you are preparing, you have to preempt what UPSC has been asking. Okay. Generally, what the candidates end up doing is, when they analyze the previous year question, they are chasing the questions that UPSC has asked this, so I will study this. UPSC has asked this, so I will study this. But UPSC might end up framing a different question altogether next year. Now, for all the content materials which are present in the market, it will be very easy task for them. They will always end up claiming that, look, now we have modified, we have brought about a new addition to the book, right? And when you buy that book for the second attempt, again, you are chasing the question in multifarious ways. So if, let's say, a minor mineral has been asked, in the next edition of the book, all the minerals will be given for you to learn. But next year, UPSC will not ask that. So that is why what is the approach that needs to be developed is something you should understand carefully when you are taking a look at the atlas. And this is something that comes to you on your own. This is not something where, if you are reliant on a particular source of information, you will be able to excel. No. So when you are taking a look at the atlas, the physical map of India, you should have that explorative tendency to look and explore around as well. For example, let's say when you are taking a look at the Malwa Plateau. Now, what are the regions around Malwa Plateau? Where in Madhya Pradesh do we have the presence of Malwa Plateau? What are the other physical features that we come across, let's say, in Madhya Pradesh, in Chhattisgarh, in Jharkhand? So that is how, whichever state that you are living in, what are the boundary regions of that state? And the boundary regions or the boundary states, what are their boundary regions? So like that, if your source of information grows organically, you will be in much greater point of confidence also, and in a much better situation to solve those questions. So that is the approach I would want you to inculcate, approach I would want you to bring to the table. Because please understand, this is a competition. Everybody almost reads the same amount of materials that you have, right? If not more. So how to gain an advantage, that is something you have to work upon. Okay. Now, after that, we come to the coastal plains. So when we talk about the coastal plains of India, so both across the eastern and the western coastline, we have a plain region which is created by the deposits of the small rivers originating from the plateaus and carrying out the deposits significantly. Now, if you take a look at the image in itself of the coastal plains gives you much amount of information. For example, if you look at the eastern coastal plain all along on the map, this eastern coastal plain is much wider in comparison to the western coastal plain. Western coastal plain is very, very narrow. Majority of the rivers are draining to the east, so they will carry out huge amount of deposits. Now, historically, all the kingdoms of the Middle Ages and the ancient ages also, all the kingdoms, they have vied and they have fought for the control of the eastern coastal plains, because they have been so very fertile due to the sediments brought down by the rivers, that they have supported multiple crops within the same year. And that is why it has always brought about a kind of a prosperity in these areas. That is why from the time of the Cholas to the eastern Gangas, everyone, you will observe, they have been vying for control of the eastern coastal plain. Western coastal plain was also something which was significantly fought about. You had the Pratiharas and the Rashtrakutas from that time itself, and then coming on to the Cheras. Everyone fought about the control of the western coastal plain, but that was largely for trading purposes, so that they can bring in or they can control the trading centers. So, western coastal plain is naturally suited for the development of ports and harbors because of the reasons that we have already looked at above. Now, here, the plains, the coastal plains, they have been named differently in different parts owing to the region that they are present in. For example, when we talk about the eastern coastal plain, this particular area, the entire portion, this is what is referred to as northern sarkars. Then after that, the southern part, that is what is named as Coromandel coast. Now within this, the Odisha coastline, if you consider, Odisha coastline is also what is referred to as Utkal coast. When we talk about the western coastline, now in the case of the western coastline is significantly broader in the region of Gujarat and the northern part of Maharashtra. So this is what is also referred to as the Kutch and the Kathiawar coast. Kutch and Kathiawar coast. Then after that, in the region where it gets very narrow, Ratnagiri southwards into the region of Goa and some parts of northern Karnataka, very little parts of northern Karnataka. That is what is referred to as Konkan coast. It is here that the coastal plains get very, very narrow. It is here that you will also come across the very picturesque and very beautiful region of Konkan railways. Ever if you get an opportunity, you should absolutely avail that opportunity and you should try to travel through Konkan railways once, because it is in this Konkan railway that you will find many different views of tunnels, very high bridges, waterfalls, and you will come across the physical feature of Western Ghats to its level best, where you will be able to find few of the smaller deltas, estuaries which are created, and this Konkan rail almost moves parallel to the Arabian Sea coastline. So it is one of the most beautiful rail lines to be on when you are traveling through. Now, it is in these months, that is in the month of late May, June, July, and August, where this becomes a very good particular region to travel through. Then after that, here you come across the Karnataka coastline. That is what is also regarded as Kannara coast. And then again, it gets broader in the region of Kerala, where it is referred to as Malabar coast. Okay, that is what where it again gets significantly broader. Now, ideally, here you will find that majority of the rivers, they will be draining into the east into the region of Bay of Bengal, right? Only two rivers amongst the large rivers that you consider in Peninsular India, only two rivers are the ones where you will find that they are draining into the region of Arabian Sea. That is Narmada and Tapi. Now, Narmada and Tapi, they are draining into the region of Arabian Sea. Why? Despite the slope of the land being from west to east? Because Narmada and Tapi, they move through a rift valley. Very good. So, Narmada and Tapi, move through a rift valley. Okay. And moving through a rift valley means what? That you have raised up portions on both sides. You have a depressed area in between. And here you have the flow of the river which is generated. So the river is already moving at a downward position, right? At a lower elevation. Now, here, when the river is flowing through already at lower elevation, will the river carry out vertical erosion? Will the river be able to carry out significant amount of sediments? No. So that is where, in this case, you will observe sediment load carried is very less. Carried is very less. Okay. Very low amount of sedimentary load is carried. Now, also, here you will observe that immediately, now if the sedimentary load carried is very less, that means automatically deposition cost is almost negligible, is almost negligible. That is why you will come across a situation where these rivers, rather than forming deltas, they are going to form estuaries. We have discussed about what is an estuary when we were discussing about oceanic salinity the previous weekend. We had discussed about what is an estuary. Estuary is an area where seawater gets inward as the river meets the sea, right? So that is where you have an estuary. So that is why, because the deposition is almost negligible, west flowing rivers form estuaries rather than deltas. Okay, they will form estuaries rather than deltas. So UPSC had asked this question in the mains examination, and the question basically was what? The question was that why is it that across the western coastline we don't have the formation of deltas, rather we have the formation of estuaries. So here, when you are trying to write an answer, always try to indicate by a schematic diagram what do you understand by a delta, what do you understand by an estuary. So generally, when you talk about a delta, in the case of a delta, let's suppose here you have the river. Let's suppose river is draining here. So this river will carry out deposits extended into the sea. And that is what is referred to as the delta formation. These are referred to as deltas. Okay. But when we talk about an estuary, estuary is what? Estuary is an area where, let's suppose this is the river. Seawater gets inwards as the river water is exiting out. So that is what is referred to as an estuary. So when UPSC has asked this question, why is it that across the western coastline you will experience the formation of estuaries rather than deltas? You have to understand that this estuarine formation or this estuary formation that you come across, that is basically, first of all, because you don't have any major large rivers which are in existence across the western coastline. Of the large rivers, you have only two of them, that is Narmada and Tapi. If there would have been many different rivers, then it is a different case altogether. But you don't have many rivers in existence. Now, first of all, that is the main reason. Secondly, both the existing set of rivers, they originate or they move through a rift valley structure. Rift valley structure, they are already moving through a region which is depressed. A region which is depressed means what? Means it doesn't have enough erosional capacity, in the sense it is not able to carry enough eroded materials because erosion will be very limited. Where is it that the erosion is high? When the materials are coming down the slope, when they are moving through an area where there's a slope difference, that is where they will gain the velocity and they will be able to erode. But when they are already moving at a depressed region, there will be lesser amount of eroded materials. So if you have very little amount of eroded materials, that means what? Deposition will also be almost negligible. It is these eroded materials that you end up depositing. But if the eroded materials are in itself not there, deposition will be almost negligible, and deposition is very much required for the formation of deltas. That is why here you will find the formation of estuaries in general. Okay, is that understood? Sai, now is the second point understood? Okay, good. So now, whereas when we talk about the eastern coastline, across the eastern coastline, you will come across the formation of both deltas as well as the formation of estuaries in general. So that is a common feature that you will find in eastern coastline. Eastern coast will have the presence of both deltas as well as estuaries. Okay, they will have the presence of both the deltas as well as estuaries. So don't think about it that if estuaries are present across the western coastline, no estuaries will be found across the eastern coastline. There you will find many small rivers draining into the sea. So many of them will be able to form the estuaries. Whereas very minimal amount of rivers they drain into Arabian Sea. You have Narmada, Tapi amongst the larger ones. You have Zuari or Mandavi in the region of Goa, very small one. Then you have Periyar and Bharatapuya in the region of Kerala. So very small streams end up draining into Arabian Sea. But many numerous number of streams and rivers, massive rivers, they drain into Bay of Bengal. So eastern coast will have both deltas as well as estuaries, which is naturally more suited for formation of harbors. Harbors and ports will be naturally found in which area? Eastern coastline or western coastline? Let me know. Good. Western coastline. And we have taken a look at the reason for this as well. Beautiful. And that is because closer to the water, closer to the coastline, you have very deep waters. That is why latest the portion of current affairs it was covered. You have the Virinium port, right? Virinium port is being constructed here. Now this is very close to the international shipping route. The international shipping route, ideally they take a break at Colombo, and that is when they move furthermore. Now, if you have now, even Colombo port is only around 15 meters deep, but Virinium offers a port depth of close to around 20 to 22 meters near the coastline. And that has got a huge scope. Large containers can come in. And large containers, oftentimes they carry a host of products, right? Maybe some product has to be supplied to Sri Lanka, some portion or some products have to be supplied, let's say to Myanmar, Pakistan, India, and so on. So when a large container comes, they bring in all those products. Now all those are then loaded onto the smaller ships, the smaller vessels, and then they carry out. This is what is referred to as transshipment. So that is why Virinium port, if developed, if allowed to develop, will be a major step in terms of economic realization of the potential offered by the western coastline. Okay, so Kandla, Mazagaon, JLN, Navasheva, or Marmugao, or Mangalore, Cochin, Karwar, all of these are the ports across the western coastline. Now here the western coast is divided into Kutch, Kathiawar coast in Gujarat, Konkan coast in the lower region of Maharashtra and Goa, Malabar coast in Karnataka, some parts of Kerala. So it is wider in the region of Kutch, Kathiawar coastline. It is wider in the region of Malabar coastline. It is here that the Western Ghats become very narrow. That is where, if you get to travel through this region by rail, you will get an idea about how this estuarine formation, this delta formation will be observed. And that is the best place to observe this. Now, western coastal plains are narrow in the middle and they are broader in the region of Gujarat and in the region of Kerala. No delta formation takes place. No delta formation is observed here. And here, the Malabar coast has got certain indentures where water comes in, and that forms very large backwaters. So, here, in many of the areas, what has happened is, suppose this is the coastline, you have a kind of an indenture, right, where seawater comes in. And then the sea has deposited some amount of sand as a barrier. Maybe a small stream or a small river ends up draining here. So this is where the seawater comes inland. Now the water in this region, which is referred to as a backwater, the water in this region, will it be saline or not? It will be saline. So that is where these backwaters create these small lakes, which are referred to as lagoons, and they are significantly saline in condition. So this is what leads to formation of lagoons, which is going to have saline water conditions. Okay, it is going to have saline water conditions. So it is here that you have the very famous boat race of Kerala that is organized. And here you have the entire economy in many of the regions. They are completely based on these backwaters, because around the backwaters, you will find that significant amount of fish population is also present. Saline fishes, okay, or saltwater fishes is something that you will find. Also, on the sides of the backwater, because the availability of moisture is there, you have coconut plantation which is carried out, rubber plantation which is carried out. On these backwaters, you also have the presence of various different houseboats. So tourism as an industry is also served. It is, in fact, the development and the protection of these which has earned the name, rightly so, for Kerala, God's own country. Because nowhere will you find natural beauty to be as diverse and as variable as you move across the Kerala coastline. It is here in the Kerala coastline that you also come across the very unique sea cliffs, one of the only sea cliffs, only few sea cliffs that you will find across the country. Where is it found in Kerala? It is found in the region of, let me know. Very good. It is found in the region of Varkala in Kerala. That is where you find these sea cliffs. One of the most picturesque locations. Had that been in some other foreign land, it would have been capitalized beyond proportion. But nonetheless, we are moving towards that kind of ecotourism slowly and steadily. Vanvi, Hindi. Okay, Vanvi, my dear friend, it is an English batch. So if you have to attend the portion of Hindi, again, I would reiterate that please find the link for the Hindi BHLP sessions, because this is an English session. So I won't be able to help you out in that case. Now, again, I will repeat the formation of backwaters. Okay, so I had Sangam Reddy and Abhijit about the formation of backwaters and the formation of lagoons. So understand this, that when we talk about the Kerala coastline, the Malabar coastline has a unique feature in the sense that it has got many indentures or discontinuities in the land from where seawater gets inward. Seawater enters inward. So if suppose this is the landmass, if let's say, I will repeat this, suppose this is the landmass, there is a gap in between. right? Where the coastal area is very low lying in this region. So the seawater will get inland. The seawater will get inland. It will end up forming a kind of a pool of water, right? And here, this pool of water will be saline in nature. Now, over a period of time, as the seawater gets inland, the sea will carry out the deposition of sand here. Remember, we had talked about the spits and the bars that are created. So, these sandbars as deposits would be created. So, in this way, a large lake of salt is created, and which is separated from the main sea by this tiny portion of sand deposits. Sometimes during high tide, water still comes inwards from this particular portion. But here, the water is said to have flowed back from the sea into the land. That is why this is what is referred to as a backwater or a lagoon. Backwater or a lagoon. And because it is the seawater which is come in, that is why this is going to have brackish or saline water. Now, in many of the cases, because it is a low-lying area, that is why the seawater has come in. It is not because some higher entity or heavenly being has blessed this area that only in this area seawater can come in, not 50 meters north, not 50 meters south. It is because it is low-lying. So that is why, because it is low-lying, many of the times small streams and seasonal rivers, they also end up draining into this backwater. Not always, but sometimes. So you have sometimes the seasonal streams or rivulets drain into the backwater. Is that understood now? Sangam and Abhijit, I hope this is understood. Okay. So that is about the eastern, or that is about the western coastline. When we talk about the eastern coastal plain is referred to as an emergent coast. Western coastal plain is referred to as the submergent coast. Always western coastal plain, that is referred to as a submergent coast. Why? Because significant portion of the region of the Western Ghats that has basically submerged underwater. During the last creation of faults, they have submerged underwater, forming a prolonged or an elongated continental shelf in that area. Whereas in eastern coastal plain, as we have talked about, that some portion has risen above water with the passage of time. So that is an emergent coast. It is much broader as compared to the western coastline. And here you will find the presence of very fertile deltas, very, very fertile deltas. Okay. Because all the rivers originating in the peninsular India, the major rivers that are present, they travel very long distance through the plateau regions, through the rugged hills, and they bring a lot of sediments that they carry, they deposit it in the region of the coastal plain. Now, because this is emergent, that is why in the region of, hence, in the region of Krishna Godavari Basin, or the KG Basin as it is referred to, Krishna Godavari Basin, we have the presence of fossil fuel, crude oil rather, and natural gas. In fact, if you take a look now, as we have been taking a look at the geological history of the country, there are many other areas that if you take a deeper look, you will be surprised by their formation. So, for example, even if you take a look at the region of Gujarat, this particular area, I will rather take you to the unadulterated image. So, this region of Gujarat that you talk about, even in this region of Gujarat, at one point of time, you only had isolated island of forms. This was not connected to the mainland. You had isolated islands here and here. Later on, by the small streams and the rivers which would originate from this area, originate from the region of Rajasthan and the Aravallis, they would carry out the deposits, and that is where some portion significantly which was underwater that started emerging up. So much portion of Gujarat has also remained underwater for significant proportion of time. That is another reason why in the region of Gujarat also, here also, you have the Ankleshwar oil fields, very rich in oil, very rich in natural gas. So whichever region have had a kind of a marine system in existence, be it the region of Rajasthan, be it the region of Gujarat, be it the region of Krishna Godavari basin, and for significant part of the history, you had the Indo-Brahm rivers that we had talked about. They had flooded this area. So that is why even in this region, Digboy, Jorhat, these are the regions where you will find significant oil deposits. So, if you know about the physiographical history of the country, understanding the mineral distribution becomes a natural evolutionary process. You don't have to learn it by heart from any particular book. Now, this brings us to another area where now we can talk about this, which UPSC had asked a question. So, when we talk about events and natural disasters like landslides, now landslides happen as a mass movement. They are nothing but a kind of a mass movement. So, where will the landslides happen? In India, wherever you have a slope, availability of water, loose soil which is present, landslides will happen. So, in India, landslides are restricted or are more commonly observed across the region of Western Ghats and across the region of the Himalayas. That is where landslides are frequently observed. Now, UPSC had asked a question. The question was, why more frequency of landslides is observed in Himalayas as compared to the Western Ghats? This was a question, a 10 marker question, which UPSC had framed. Now think about it. Why do you think Himalayas will have more landslides as compared to the Western Ghats? First of all, if we talk about the reasons, Himalayas, they are an unstable landmass. There still you have the establishment and the rising of the slope. So Himalayas is an evolving landmass with unstable slope. Let me know of the reasons that you can think of. Is an unstable or is an evolving landmass with unstable slope. Then reverse and slope, Ambika, deforestation, Ajit. Okay, continental convergence, more rivers drain out of it. Anshu, okay. Aarti, very good. Benita, good. So, when we discuss about the Himalayas, we also discuss about the fact that these are active tectonically. Tectonically active means you have higher frequency of earthquakes which happen. So whenever you have very frequent earthquakes which happen, the slope gets destabilized and the materials they start coming down. So seismic zone Himalayas are active seismic zones. Okay, then after that, what can be the other reason? The slope across the southern slope of the Himalayas is significantly steeper. So it becomes easier for, and it has got a greater height as well. So that is why the materials they start to naturally come down in the slightest availability of moisture. So nature of the slope and a greater height. Then in the region of the Himalayas, you have a lot of natural rivers, large number of rivers drain through. So whenever you have the conditions of floods, they can bring about significant amount of landslides as an associated process, as an associated outcome of it. Then after that, here another factor can be greater frequency of cloud bursts above the southern slope of the Himalayas. They bring in flash floods. So greater frequency of cloud bursts, they bring about flash floods. Okay. After that, Western Ghats is densely forested. And forests and trees, they will bind the soil in its place, not allowing its movement. Whereas the southern slope of the Himalayas, they, they are basically devoid of forest cover, or they lack forest cover in general. That means a lot of loose materials which are ready to flow and ready to move down. So lack of forest cover as compared to Western Ghats. Then after that, what can be the other factors? Anticlinorium and synchlorium are also the factor. See, even if you talk about anticline and the syncline in general, and a series of them, what is referred to as a chlorium. So here, even they, when it narrow it down, even there also you have to talk about the slope characteristic, whether the slope is very steep, a step-like slope, etc. So just when we talk about the hogback topography, that also is sufficient here. No, orographic rainfall pranay will be caused in the case of Western Ghats also. In fact, if anything, Western Ghats they experience much more orographic rainfall as compared to the region of the Himalayas in many portions. Seasonal streams that can be included in this particular portion. Then the other factor will be unsustained unsustainable tourism leading to significant amount of construction of resorts, hotels, etc. on the steep slope, which creates an instability in the slope. So you have construction across steep slope, and that makes the slope unstable. Slope unstable. Good, Ambika. So then after that, you have mining activities, especially in the northeastern portion. Mining activities. And these mining activities bring about what? The use of detonators, explosives, etc. They also create instability of the slope. Okay. The lithium resources which have been found in JNK, they are very far away from being mined. You have the Geological Survey of India set to carry out another kind of uh, recce activity or another kind of verification, and then it will be finally approved, and then dependent upon the amount of ore available, a decision to mining will be taken or not. So it is a long term process. Even mass wasting is more in Himalayas due to the slope. So landslide is a kind of a mass wasting, isn't it? Good. Another factor by Ankit, that is development of reservoirs. Reservoirs. This again, what it does is in many areas that water seeps in within the rocks, and that brings about a kind of a lubrication in for the materials to flow down the slope. So water starts penetrating from these reservoirs. Reservoirs are very massive storage structure, very large storage structure. Now these large storage structure, they will exert pressure on all sides of the mountains, and there, through those tiny cracks, water gets inwards. It weakens the slope from inside, and because there is water, it induces a kind of a flow across the slope. Okay, across Himalayas. So these are your various factors why Himalayas experiences greater amount of landslides. So how many factors have we talked about? So we have talked about 9 different factors, 9 different points. It is a 10-mark question. So in that, for all these points, I hope that you will be able to write at least a couple of sentences about how this leads to a kind of a landslide. So if a question like this is asked in the introduction, first of all, you have to write about that landslide, which is a form of a mass movement, is observed across both the region of the Himalayas and the Western Ghats prominently, especially during the rainy season. Now, as a result of, or basically, when you have these landslides, it is the large or the mass scale movement of the materials down a steeper slope in the availability of moisture. So, that is when, after that, you write a linkage for the body part. That greater frequency of landslides are observed in Himalayas because of a set of geological as well as tectonic factors. And then in the body, you start writing about these, each of the points, write a short heading, underline it, and then write a couple of sentences elaborating it. That way, if you are able to write around 9 to 10 points and then conclude, that is something which will yield you very good marks in the examination. Okay. Now, then after that, we come to the portion of the islands and the formation of these islands. Now, islands basically, they are a kind of a strategic and economic asset that we talked about yesterday. That this is a kind of an asset that India has. Now, this increases our reach beyond the territorial regions of the country, much beyond the territorial regions or the mainland of the country. Now, these islands, they provide as centers for biodiversity. These prove to be the centers for tourism, ecotourism in particular. These prove to be the centers for even defense purposes, providing an extra layer of defense. So they solve multiple different purposes. Now, how are these islands formed? So when we talk about Lakshadweep, how is it that Lakshadweep has been created? We have talked about it yesterday itself. Very good. Lakshadweep has had a kind of a coral origin. If I may take you back to the image exhibited earlier, so if I can take you to this image, observe here the presence of Lakshadweep here. You'll find a shallower region, light blue area, extending all the way to the region of Maldives also. In fact, if we further take a deeper look, it extends significantly southwards, right? So it is across this entire region that we have experienced a kind of a coral growth. That is why Maldives, Lakshadweep, they are very, very similar in terms of the formation of these coral islands. You have Maldives very few, a couple of 100 kilometers from Lakshadweep coastline. Maldives, on one hand, with the same coral islands, that earns billions of dollars in terms of tourism revenue. Lakshadweep, on the other hand, earns almost negligible amount. Despite having very pristine beaches, very clean areas, we earn almost negligible in terms of tourism potential. And that is why, because there have been many disputes which have come up into the news in the recent times. So always you can expect the question, if you are appearing for the examination next year or even this year, you can expect a question to be asked about the tourism potential of island territories like Lakshadweep. Here, there has been a significant dearth of connectivity, a dearth of basic facilities, basic infrastructure that is lacking in Lakshadweep. The same kind of feature is present in Maldives, but they have developed an infrastructure around it. Now, after developing the infrastructure, they have managed to control the biodiversity in that region as well. Biodiversity is not wasted significantly. In Lakshadweep, the fear has been that if you allow the developmental process, the normal fishermen folk who have been surviving there on the fishes for a long period of time, their occupation will be disturbed because of the certain prohibitions. Obviously, if you develop a resort in a small island and an individual resort on that island, the resort people won't allow the fishermen to carry out their regular activities. So there is that kind of a fear. But in general, it has been found out across the world, wherever there is tourism, it brings about an exponential income, not only to the direct people benefiting, but from the associated activities as well. If more people come to Lakshadweep, more people will be, let's say, indulging in the normal dietary habit of eating the local cuisine. So the fishermen will get a better produce or a better price for what they catch. Also, there will be more water activities, water sports, that also generates you significant amount of revenue. But the only problem here is that during those construction activities there will be marine pollution. So that if that is taken care of, if that is sustainably managed, then Lakshadweep has got enough potential. Last year you had the union government floating the idea, and the basic idea was floated of the development. It cleared certain laws which would pave the way for development of infrastructure in Lakshadweep. Now, it was met with large scale protest. After that, it was taken on a back burner and that issue was frozen. So, if that is where we need a kind of a middle ground, the ground cannot be that absolute protection of nature. If that is the case, then nature is at its pristine best in the entire portion of peninsular India. No highways, expressways should be constructed at all. Now, how will people move? So, people, if they are not able to move, how will we generate economic activity? So that is where you have to find a kind of a balance in between. So that should be your approach when you are writing the answer for the tourism potential in Lakshadweep. Now, coming to the region of Andaman Nicobar. Now, before we observe or before you dive deeper into the portion of Andaman Nicobar, in the region of Myanmar and in the eastern portion of India also, you have multiple fold mountains here. You have the Naga Hills, Patkai Bum, you have the Lushai or the Mizo Hills. Here you have the Pegu Yoma, the Arakan Yoma, the Tanasirim mountain ranges. Now, here, observe one particular aspect. Observe that the water is shallow in this region, which means there is some underwater formation, a ridge like feature. And then eventually, you will observe the formation of a kind of an arc like feature extending all the way through. So, Andaman Nicobar Islands, they have had a kind of a volcanic origin associated. When we talk about Andaman Nicobar Islands and Nicobar, they have a volcanic origin. Why and how? So, here again, right at the time of collision of the Indian plate, you had the oceanic crust of the Indian plate colliding with the oceanic crust of minor Burmese plate. Burmese plate also considered to be a larger part of the Eurasian plate. Minor Burmese plate brings volcanoes and seamounts. Now, it is in many of these seamounts that on top of it, you have had the development of significant proportion of corals. For example, Havelock Islands in Andaman Nicobar, they have developed over this seamount, right? So that is where you have the formation of these volcanoes. Now, it all forms, if you take a look at the map carefully, you'll find that all of it forms a larger part of what is referred to as the Indonesian arc. The Indonesian islands that are created, the island arc which is created, it follows the larger shape of it. Let me show you with the help of an image. Observe here the shape. The shape is very similar to what you observe across the island arc of Indonesia. It is because the convergence of the Indo-Australian plate is happening here. That is why here you have the Java Trench, the Sumatra Trench, which are present. It is here that you had the massive earthquake around 8 in magnitude, which occurred on 26th of December 2004, which triggered a massive tsunami. Why was the earthquake there? Or why did the earthquake happen here? Because you had an oceanic convergence taking place, convergence and plate movement happening. Barren Islands is the northernmost volcanic eruption across this entirety of the arc. Otherwise, across this arc, you will find very violent eruptions and also calderas. For example, you have the Krakatau eruption also lying across this arc region. So that is how you have the formation of these particular Andaman Nicobar Islands. Here, in fact, preceding this, you have a kind of a trench also, the Andaman Trench, which is present in this region. Okay, just in front of the Andaman Nicobar Islands. So that is how They have been created. That is how they have been formed. No, Anshu, it is not a hotspot. Had it been hotspot, you would have frequently observed volcanic eruption now and then again. But it is not a hotspot. It is an oceanic convergence. So formation of it. So think about it. The Indian plate and the portion of the Burmese plate, they have underwent a collision. So it is a typical ocean collision or convergence. The Indian crust, being the heavier one, undergoes sinking. This is where you have the formation of the Andaman Trench also. These portions will melt, will start to rise. They will lead to formation of volcanoes, many of them being able to emerge above water. Few of them do not emerge over water, they form seamounts. And then on top of these seamounts, many of the times you will observe corals also forming coral islands. In these cases, in few of the areas, the corals will develop above them. So you have volcanic islands, coral islands, both of them are present. Overall, if you take a look at the larger picture, if suppose this was in the Eurasian plate, the minor Burmese plate on this side, the Indian plate, when it underwent the collision, it had the oceanic portion as well. So let me represent this as the oceanic portion of the Indian plate, right? And the land portion, the continental crustal portion, extended somewhat like this. So it is along these lines where you have had a convergence and the formation of Andaman Nicobar Islands. Okay. The Indian government doesn't face issue in handling places like Andaman, Nicobar, and Lakshadweep as they are far away from mainland. No. So you have a very well defined civil service cadre for there, the Agmut cadre, and then there you have, for example, Andaman Nicobar Islands. This is the only place across the country where you have a joint unified command of the Army, Navy, Air Force. Generally, what happens? People in the army, they will report to army, or superiors in the army itself. People in the navy, they will report to the superiors in the navy. People in the air force will report to the superiors in the air force. Andaman Nicobar Island is one of those areas where, in order to bring about a better strategic reach, in order to bring about a better working condition, also, you have the joint armed command or the joint theater command which has been developed. So all of them, army, navy, and air force personnel, they report to one individual there. So you have had various different activities and various different administrative controls, which makes it very easy. Yes, the tri-service command. Okay. So that is about the region of Andaman, Nicobar, and Lakshadweep. I'm sure that you will be able to write about the aspect of the importance, the strategic importance, the economic importance, importance for defense purposes as well, and importance for biodiversity also. Convergence with Burmese plate or Eurasian plate for Andaman. So, Burmese plate is a minor plate generally associated with the larger Eurasian plate. Okay. So, Burmese plate is a kind of a division here, a minor division that you will observe, which is a larger part of the Eurasian plate, but this is a minor separate plate. So, if you have to pinpoint it, you can write Burmese plate, or you can also write the minor Burmese plate, a part of the larger Eurasian plate. You can write anything. Okay. So this is basically Andaman Nicobar and the region of Lakshadweep. Then we come over to the drainage systems, right? Do we have any kind of doubts up till now? Any doubts that we have? Feel absolutely free to ask. Not the doubts outside the portion of geography. Please restrict your doubts to the portion of geography, not your everyday problems. So any doubts that you have, feel absolutely, don't hesitate and feel absolutely free to ask. So no doubts, I presume. Or maybe we have not read the subject till now to develop doubts. It is ocean collision. oceanic crust collides with another oceanic crust, right? The oceanic crust of the region of Indian plate collides with the oceanic crust of the Burmese plate. Okay, so I presume we have no doubts, and then we proceed further. It is where it is one small one difference between. Okay, I get a feeling that just for the name of asking doubts, many of us are we are framing doubts. So okay, one small difference between a storm and a cyclone. Storm is a condition of atmospheric turbulence and imbalance which ends up creating very heavy winds, very strong movement of the winds along with thunder and lightning. That is a storm. And when we talk about the cyclones, it is where you have an isolated or a small low pressure which develops a circulatory movement of the winds all around. So that is basically the difference. And beneath a Great Plain Formation. Okay. Uh, Let me solve that question about the Great Plain Formation. Yes, Subhash, both are formed as a result of low pressure. Storms basically they don't have that all they will not always have that circular motion. Cyclones will always have that circular motion. Okay. So thunderstorms, you would have heard about the term thunderstorms. Cumulonimbus cloud, thunder, lightning, very heavy wind movement, a storm. But that is not a cyclone. Cyclone is a circular movement. Lakshadweep is coral in origin. Are these corals formed above seamounts in many of them? Yes, Abhijit. Good. So what I would want you to do is open up the map of the physical map of the world. Look at the region of Lakshadweep. Look at the region of Maldives. You will find a chain of these ridges that continue almost up till the central portion of Indian Ocean. It is there that you will also find islands such as Diego Garcia, which is in very much news. Diego Garcia is what? Diego Garcia is basically the military base. I hope we are aware of Diego Garcia and its importance. It is a US military base, one of the active presence of United States assets, armed forces assets in the Indian Ocean. So it is across the same mid-oceanic ridge that you will find Lakshadweep, Maldives, all of them. Okay, and Anshu, transform plate boundary also observed between Indian plate? Not particularly so. Because as I told you, once that convergence happened with the Eurasian landmass, the Indian plate swiveled and then had a collision on the east. That is the swiveling and the movement of the collision. That is what undertook a kind of a convergence. Ankit, only reason of rainfall during summer is convection rainfall, or other reason also do we have? So we have the low pressure centers creating a kind of active low pressure creating a cyclonic rainfall. For example, um, 10 days back, you had very active rainfall in the eastern part of India and in the central portion, southern portion of India, because of the development of cyclonic centers or low pressure centers around the region of Vidarbh in Maharashtra and Bay of Bengal. So that also brings rainfall. Okay, so I have one question from Binita about the brief formation of Great Plains. So here, Binita, I'll take the help of a piece of paper. So pardon me for a moment. Let me get the piece of paper and we'll talk about it, the entire process. So here I have with me a piece of paper. Now think about it as a kind of a landmass. Now, generally, if I provide a kind of a fold, observe that while there is an upfold, there is a development of a downfold as well. Always this will happen, right? In order to gain a kind of a equilibrium, you will not come across a situation where everything is folded and turned like this. Whenever there is an upfold, there is a kind of a syncline or a kind of a geosyncline which is created as well. So this kind of geosyncline was created in front of the Himalayas, and that is where water started filling in. The Indo-Brahm rivers, that is Indus, Ganga, and Brahmaputra, they started filling in that particular gap. And that is where it started having the deposits of sediments. Eventually, with the creation and the formation of the Malda Gap, all that water exited into the region of Bay of Bengal, leaving behind these deposits, and these deposits have been accruing ever since that time. That is why you find that even after a kilometer thick or more of deposits, the height of the northern plains is still at the sea level, almost at the sea level. That means what? That means at the origin point, it would have been much, much deeper. Understood? Okay. So I guess that is about the doubts. So now we proceed into the drainage system. Now, here, what is relevant for your prelims and what is relevant for your mains? For your prelims, you will get questions from the aspect of types of drainage, drainage pattern, okay, major river systems when we talk about, and their tributaries, okay. So these are the things that you will experience, or you can expect questions to be coming from in the prelims examination. When we talk about the mains, ideally, I suggest all the candidates, those who ask for my suggestion and those who deem our suggestion to be valuable enough, I suggest all the candidates to have a preparation for the orientation of mains. Prelims automatically comes to you if you attack the level of basics and the level of concepts to that extent. Prelims portion will automatically come to you. Prelims in many of the forms is very unexpected. That is where UPSC plays all its hands, and mains is to a large extent expected that it will play around certain small areas and certain poles around which the entire portion will revolve. So if you prepare fully along with the lines of the mains examination, that will enhance your confidence to an extent that revision for prelims etc becomes a kind of a very routine process, and that is where you will eventually be able to fetch very good marks and you can ensure your success. Many of the candidates, they will have a preparation only for these topics because their target is, and we get to know that when we interact with the candidates, we get to know if the candidate's target is prelims or mains. No disrespect meant for anyone, but if your target is only the prelims, when you achieve it, you become satisfied, right? So UPSC does not give out any participation certificate that this is an individual who participated in the exam. So what is the benefit of getting through prelims and not getting through mains, rather than, other than some bragging rights that you will gain in your immediate circle, immediate close friend circle? So when you go for a chai gossip or a coffee gossip, that is where you will be able to flaunt that, I qualified prelims thrice or four times. But beyond that, there is no scope and no benefit out of it. So always prepare about the questions which are going to be asked in the mains. So in the mains, what do you get? So questions about frequent floodings, floods of Himalayan rivers, then interlinking of rivers, then we also get a question about water scarcity and achieving water security. Now, this particular topic, you will gain an idea about it after you have read the portion of, let's say, the drainage system. You have read the portion of agriculture and the population aspect. There you get an idea about why water scarcity is prevalent across many parts of the country, especially the northern plains of the country, and what can be the solution. Rainwater harvesting, the aspect of misutilization of water in agriculture needs to be stopped, sustainable agriculture, sustainable farming, sustainable irrigation methods, all of that you will automatically learn there. So you have these sort of questions which need the application of one of the very rare qualities in the sense not available with majority of the candidates, and majority of the candidates don't have that quality, and that is application of logic. So just by your application of logic, you'll be able to solve these kinds of questions. Even the questions, for example, what are the problems faced by urban India or urbanization? What are the developmental issues faced in urban India? All those, these are your logic based questions. These are not your textbook based questions. So as soon as you start to inculcate the habit of applying logic, you will be in good hands. Okay. So here in drainage system, first of all, we'll be studying about the basics of drainage. We'll be talking about the types of drainage that you have, the drainage pattern that you have, and then we'll be moving on into the river systems of India. Now, drainage is what? The movement of streams and rivers. Now, have we ever come across a scenario? At least I have not. I don't know if you have. Have you ever come across a scenario where, if this is the slope of the land, river originates from here and then moves like this? Any of us who have come across this scenario, please let me know. I'm sure you would not have come across. What does that mean? And why I have asked this question? That basically tells us a unique characteristic for all the drainage. It knows only one principle, that is following the slope of the land. Whenever a new land gets created, slope feature, directionality of the slope, height, these are the natural attributes that a topographical region develops. And after some time, when, let's say, the land has stabilized, sometimes when you have very high altitude lands, for example, Himalayas, Alps, and ancient Aravallis, there you have significant amount of ice and snow accumulated over a period of thousands, tens of thousands, and millions of years. They will start to melt and they will start to drain. They form the rivers and the streams. Or many of the areas, as we observe in the case of the peninsular part of the country, many of the regions, they have got a kind of a topographical feature where, let's say, in one particular area you experience very heavy amount of concentrated rainfall. So slowly and steadily over a period of time, this will continue to supply in the form of stream to generate a river. So when you have a river or a stream which moves in an area, it drains that area along with its tributaries. That is what we refer to as the drainage system. Okay, so that is what is referred to as the drainage system. So drainage system talks about here the flow of water through well-defined channels, that is referred to as drainage, and network of such channels is what is referred to as the drainage system. Network of such channels, that is what is referred to as the drainage system. Now, they are governed by the topography of the land. What is the topography of that region? That is what is very relevant. That is, for example, what is the slope characteristic? What is the nature of the rock? What is the steepness of the slope? How old is the rock? For example, if in the same region you have sedimentary and igneous rock, always igneous rock will be eroded much easily as compared to, or rather, sedimentary rock will be eroded much easily as compared to the igneous rock. Why? Igneous rocks are harder. In a region where, let's say, a rock is 500 years old, and in other region, the rock is 500 million years old, the older rock will be much weaker, easily eroded. So the drainage pattern which will develop will be very different. Right. So depending upon the topography, the slope feature, the characteristic of the landmass, the nature of the rock, the age of the rock, all these factors end up determining the characteristics exhibited by the drainage system in any particular place, any particular region. Now, the river drains water collected from a specific area, which is a catchment area. What do we mean by that? So, for example, let's suppose I have a mountain system from where the river is originating. Okay, let's suppose I have this as a mountain system. Now, the river, let's say, is originating from here and is draining down the slopes in this region. Now, let's suppose there is significant amount of rainfall which is observed in this region. Now, eventually, this rainfall will lead to some water. Whenever you have rains, you would have observed that water starts draining in a particular direction of the slope. In whichever part of the country you are living in whichever part of the city or suburb that you are living in, whenever there is heavy rainfall, you will observe that water drains in a particular direction. And eventually it will drain to a nearby stream or a nearby drain. That drain will go where? That water will drain into the river. So we can say that the river is getting water even from this area, isn't it? If it rains, let's suppose here, and if you have a small stream originating from here, this will also end up draining its water into the river. So the entire region, the entire area from which the river gains its water, that is the catchment area. Okay, so here you have the image. So observe this, that if, let's say, it drains in this entire area, even if it rains here, even if it rains here, even if it rains here, all of that will feed to the same river. So that entire region from where water is fed to the river, that is the catchment area. Then the drainage basins, they are divided from each other. And how are they divided? Basically, you will observe there is a physical barrier, a topographical barrier, which divides each one of them. For example, let's take the same case. Let's take the same example. If there is a rainfall in this region, that water will end up draining into this river. If there is a rainfall in this area, will it drain into the same river? No. That rainfall, let's say there is a rainfall which happens in this area, it will basically have a runoff and will generate a different river altogether. Right? For example, if you observe the movement of the river Ganga and Indus in general, let me take a look at the image associated with it. Let's suppose I give you this image. Observe this image carefully, very, very carefully. So here, observe this particular portion. This is what demarcates the origin of river Indus. This is what demarcates the origin of river Satluj. Now observe Satluj. Satluj drains like this. Okay. In this portion that we have drawn, the flow is same, in the same direction as river Ganga, as river Yamuna. Satluj continues its flow in the same direction, but look at Yamuna and Ganga. They change their direction. Why? Do you think they got an invitation from Bay of Bengal that it is a more happening place? Your life will get boring when you go to Arabian Sea. That is why they turned their way into Bay of Bengal. No, there is a kind of a topographical obstruction, a physical barrier. So here in the plain region, in this area, the plains, they have a particular height. Also here you have the Delhi ridge portion of Aravallis. So this is what is a watershed. Watershed typically refers to those areas where you have a kind of a delineation of the two different drainage systems. So when we talk about the drainage basins, they are divided from each other by a topographical barrier that is referred to as a watershed. That is a boundary line separating one drainage basin to the other. For example, that is also what is referred to as a water divide in many of the cases. For example, when we talk about the Indus and the Ganga River basin and Ganga River basin, these are separated from each other by the Ambala water divide. Ambala water divide. So this is a kind of a topographical barrier, and that topographical barrier is also what can be referred to as a watershed. So watershed is what? The boundary line separating one drainage basin to another, and it is a kind of a topographical barrier. What do we mean by topographical barrier? Might be an elevated area. So in that area, there is a delineation. Water from one side will go in one side or one direction, and in other side, water will move in a different direction. So that is what we have as the watershed. Okay, understood? Watershed is single channel of river. Where did you get that conclusion from? Watershed is not a channel of the river. Look at the definition, my dear friend. What is watershed? Drainage basins, they are divided from each other. Drainage basin is what? So when you consider river Ganga, now the entire portion of river Ganga and its tributaries is a very large area. That is a drainage basin, right? Indus, along with its tributaries, will form a very large area. That is the Indus River Basin. Now, Ganga River Basin and the Indus River Basin, they are separated from each other by a kind of a topographical barrier, right? Otherwise, why doesn't water from both Indus and Ganga end up meeting? So they are divided from each other by a topographical barrier. What is a topographical barrier? What do we understand by topography? It is a kind of a land feature, right? The variation in terms of land that we have. So when we have the aspect, okay, how many of us we don't understand the meaning of topography? First, let me know that. How many of us we don't understand the meaning, or we have no some doubt in the meaning of topography? None of us. So that means all of us understand the meaning of topography. How many of us we have no clue about what is the meaning of barrier? Any of us who have a doubt in the meaning of barrier? What is the English meaning of barrier? Any of us? So none of us. That means everyone we know about the meaning of topography. We know the meaning of barrier also, right? Now, what is Sai Babu? That is what I'm trying to do. Please hold on for a brief moment. That is why I'm asking, What do you understand the meaning of topography? Do you understand the meaning of barrier? If we understand the individual meaning of both of them, the combined meaning should be understood easily. So what is this topographical barrier? When I say when we were discussing about the aspect of orographic rainfall, we discussed that it is a kind of a physical barrier offered in the passage of the winds. There also we use the terminology barrier. So what was the meaning of barrier in that case when we were discussing about orographic rainfall? There we basically discussed that wherever you have a mountain that offers an obstruction in the movement of the winds, that is why the winds are lifted up and you have occurrence of rainfall, right? That was a physical barrier. Now, what is a topographical barrier? Now, if suppose you have a condition of a landmass, let's suppose you have the condition of a landmass, which is like this, and let's suppose you have the landmass like this. Let's suppose. Okay. Let's suppose this is a kind of a landmass. Now here we have a kind of an upland, an elevated portion. In this region, we have a kind of an elevated portion. Now, here, if I have a river which is flowing, let's say, I have a kind of a river which is flowing in this region. And I have another river which is draining into this area. Let's name this river A. Let's name this river B. Now the water of A and B, they will meet each other. Is it true or is it false? The water of A and B, they will meet each other. Is it true or is it false? False. Okay, true. Why do you think it is true? Let me know. Why do you think that it can meet each other? In general, they won't meet each other. Why? There is a kind of an elevated area in between. Now, can I say that this elevated area, and listen to this portion carefully, all those of us who have not understood the portion of watershed, this elevated area, can we say that this elevated area forms a kind of barrier in between A and B? We can say that. Which kind of barrier? A topographical barrier, because it is feature of the topography. So can we not name this as a topographical barrier? Sai and Arti, kindly let me know if you have understood this. We can name this as a topographic barrier because it is the variation in topography which has created this kind of a barrier, which is separating the water of river A and separating the water of river B. So if, let's say, there is occurrence of rainfall in this area, if there is significant occurrence of rainfall in this area, will it ever go to A? Never. It will always go to B only. If you have occurrence of rainfall in this area, will it ever go to B? Never. Because it is separated by a kind of an uphill barrier of sorts. So this is what is regarded as a watershed. Watershed separates two different drainage basins. So whenever we have a watershed, this is a kind of an upland region which separates the two different flowing streams because the slope in itself is changed. So drainage basins, they are separated from each other, they are divided from each other with the help of this barrier that is called as watershed. Any of us who have any issue in that, or we have not understood this, please let me know. Sai and Arti in particular, have we understood this or have we not understood this? Okay. Vishal, have we understood the meaning of basin or is that still not understood? When we say a drainage basin, it includes the flow of the main river along with the various different tributaries. That is what is regarded as a drainage basin. Okay? River along with its tributaries, that is considered, the region is considered as drainage basin. Flow of river and its tributaries. Okay, understood? Good. Now we move on to the types of streams or rivers in terms of how they appear to flow like. Okay, so we'll cover this area, but before this, we'll take a break. Drainage basin and river basin is the same. Yes, Benita, that is correct. Before that, we'll take a break and then we will be back and we will cover this area. So we'll take a break, 15 minutes, relax, and be back. We'll cover about the sequent, insequent streams, what are their kinds. Okay. A confirmation about the audio, please. If the audio is clear and available, kindly confirm the same. Abhishek, is Indus River flow in western side, then there is no delta form in the Indus River. Indus forms a very wide delta, a very large delta, before it meets the Arabian Sea. And you have to understand why river Indus forms a delta. Because it moves across a very large area, and that is where it carries out huge amount of sedimentary load. That is why it is able to create or deposit those sediments to form the delta. Okay. Now, let us take a look at the classification of the streams. Vishal, we have refineries in the region of northern plains due to historical presence of 4D. Refineries are very different from the regions where oil extraction takes place. We have refineries in the region of, in the northern part, we have refineries in Panipat, Mathura, Barauni in Bihar. Now, these are your refineries which are closer to the market. Refineries are where crude oil is brought about and filtration is done into petroleum, diesel, kerosene, tar, etc. These are not the places where extraction is done. Extraction of oil across is done across the Assam plains, and there you have had a historical reason because of accumulation of water, formation of a marine area. Okay, I hope that is understood, Vishal. Yes, Benita, you can think about it, or think about it as the opposite of it. Catchment area is generally slightly larger as compared to the basin area. Okay, so now we come at the, or we take a look at the classification of the streams dependent upon the flow, the nature of flow that these streams have. Accordingly, we have the classification as sequent and insequent. Overall, just keep one thing in mind, that regardless of whichever stream or whichever river we are talking about, all those rivers will end up following the slope of the land. All the rivers will follow the slope of the land. No river will rise at a lower region and move to a higher region. Always the rivers will originate at a higher region, high altitude area, and move to a low altitude area. So, what is this classification about? So, basically, when you take a look at certain rivers, they appear to be defying the slope of the land. For example, take the case of River Kosi. Now, that River Kosi ends up cutting through the region of Himalayas. Now, ideally, it doesn't make sense that how is it that one river can erode through these mighty mountains? So it appears to be defying the slope, right? But when you take a case of River Ganga, originates from high altitude within the Himalayas and drain into the plains before draining into the Bay of Bengal. So that is where it appears to be taking or following the slope of the land. So here, that is the basic classification. So, depending upon the nature of flow, you have the sequent stream and the insequent stream. Sequent streams are the ones which appear to be following the slope of the land. Appear to follow the slope of the land. They will have an appearance that they are following the slope of the land. Whereas insequent streams, they appear to be defying the slope of the land. Appear to defy the slope of the land. So let us take a look at each one of them. Let us try to understand what they are and how they are created. So we start first of all with the sequent stream. Sequent stream is also divided into consequent and subsequent. Now, before moving into it, always advisable that any portion of geography that you come across, any terminology that, let's say, we are unable to make sense of any terminology, look at the English meaning of it. Many of the times, the English meaning of it will give you an idea about what that stands for. So, for example, consequent. Consequent means what? That, let's say, after an event, right? So let's say a land has been created, and immediately owing to the slope, you have the movement of a river stream. That is consequent, a resultant of something. Then when we have subsequent, so after an event has taken place, then something else has happened. So after, let's say, a stream has originated, after that another stream has originated, and again following the slope of land, that is subsequent. So when we talk about consequent and subsequent streams, so consequent streams, they are a direct consequence of the original slope of the surface where the drainage is developed. That is, the streams that follow the slope of the land over which they were originally formed. For example, let's suppose, again, let us talk about a mountainous region. Okay. Let us talk about a mountainous, and let us assume a mountainous region somewhat in this proportion. Now here you have this as the landmass. Now, if a river originates from here, follows the slope, and eventually the river manages to drain through this area. Now here the river is following the slope. After the land has been created, after the land has been formed, the river is merely following the slope of the land. So this is what is regarded as a consequent stream, also referred to as a master stream or the master consequent. So this is what is regarded as the consequent stream, consequent or master stream, or master consequent. This is the mainstream. For example, you can take the case of River Ganga. River Ganga stands as an ideal example of the consequent stream. Okay, here I will write example River Ganga. Now, then we have the subsequent. Now, subsequent stream, they tend to originate after the master consequent, and they will also follow the slope of the land. Now, there is a lot of debate about the fact that whether the subsequent stream originate at the same time or always after the master consequent. Now, there are debates about it. There are various theories which tell us that it might be possible that subsequent stream also would have originated at the same time. But subsequent streams, they end up generally meeting with the master consequent. So let's say this originates and ends up meeting as a tributary. So this is what will be referred to as a subsequent stream. Okay, example River Yamuna. Okay, example Yamuna. Now Yamuna also follows the slope of the land, but it ends up meeting the master consequent. So that is where it can be thought to be as a subsequent. So subsequent streams, they generally end up originating after the master consequent has come into existence. That is the prevalent theory around it. So both of these will be following the slope of the land, and hence they are referred to as sequent streams. Both of them, they are referred to as sequent. Now, when we talk about insequent, they will appear to defy the slope of the land. And here you have two types, antecedent and superimposed. So what are those? So when we talk about antecedent, again, take a look at the English meaning of it. It means something which has been in existence before a particular event, right? So many of the rivers, Indus, Satluj, you also have the case of Kosi, Brahmaputra. Now all of these will be able to cut through the Himalayan mountain ranges, the very high, lofty mountains of Himalayas, almost impossible to cut through. You'll find that many of the streams, they are doing that. Now, how is it possible? Is it possible that they have managed to erode the mountains to such an extent that they are able to erode all the three ranges and eventually are able to cut through it? No. So basically, these rivers would have been in existence before the folding process would have happened. And that is why all around them the folding would have happened, and these rivers would have continued to flow, continued to have eroded any kind of fold on their river beds, and all around them the land has risen up, but they are at the same level. So for example, let's suppose we consider a land portion. Let's suppose we consider a portion of the land. And let's suppose here you have a river which is moving. Now, due to certain processes, geomorphic actions, etc., let's suppose there is a kind of a compression which has been initiated. So compression means there will be a folding happening here. There will be a folding happening here. There will be a folding happening here as well. Here as well. Here as well. Here as well. So like that, the ground will start to get folded. Now, any folding which will happen on the river bed, the river will be able to erode it very easily because the rate of folding is always slow. So after some time, you will observe that all around that river, the land has risen up as a fold. And the river, because it is continuing to flow across the same channel, continuing to erode any kind of fold on the land, it appears to cut through the mountains. For example, here is the image. If you observe, the river has been flowing through this area for a longer duration. Let us say river has been flowing through this area. Now, over a period of time, you observe what? Let's say there is a compression. Now, all around it, there is a folding which has happened. But the river has managed to erode any folding observed in the riverbed. So the river will maintain its course, maintain its position of erosion, while all around it, the region gets folded. Isn't it? So here, this is an antecedent stream. So antecedent streams, they predate the upliftment of an upland or mountain across which they have maintained their present courses through continuous downcutting of their valleys. That is, any amount of folding on the riverbed, they have eroded. So all around it, as the land has risen up, the rivers have maintained their natural pathway of flow. So that is antecedent. Example, you have river Indus, river Kosi, river Brahmaputra, etc. River Satluj, that is also an example of antecedent. So these, they appear to defy the slope. eventually understand all the rivers will follow the slope. You will never come across a situation where if the land is like this, a river has originated from here and is defying gravity and moving upland. You will never come across that situation that a river has originated in the lower elevation and it is moving to a higher elevation. It can never do it on its own. So everyone will follow the slope. But here they appear to defy the slope because they are cutting through the mountains. Ideally, if they had to follow the exact slope, then when, let's say, you have the mountains, rather than cutting through, they would have changed their path, they would have deviated the course. So this is insequent. Okay, so they appear to defy the slope. Appear to defy the slope. By cutting through the mountains and the uplands. Hence, they are insequent, or hence they form or fall into the category of insequent. Now, here you have another category in insequent, which is referred to as superimposed stream. Now, before moving into the very definition of superimposed, let us understand few of the basics, and then we will have a better clue about what do we understand or what do we mean by superimposed. So here, let's suppose we talk about superimposed. Now, before that, let us think about a couple of scenarios. Suppose you have a landmass which is made up of very hard igneous rocks. Okay. Let us suppose this is the topography of that landmass. Okay. Let us suppose this is made up of igneous rocks, very hard igneous rocks. Now, if I ask you that where is it that ideally you expect the rivers to flow? Do you expect the river to flow naturally in this position, position 1, or do you expect river to flow naturally in this region, let's say region 2? Out of 1 and 2, where do you think you will expect the natural follow or the flow of the river? Good. In the first situation, that is the natural expectation, that depending upon the slope of the land, the river should flow from that area, from the low-lying area, because that is a depression. So if the river would have flowed through that area, river might have cut through this area by erosion. It would have eroded this area quite significantly. But here there is no river which is flowing. Okay. This is just to identify the slope of the land. Now these are your hard igneous rocks. So if the rivers would have originated at this point of time, we know where it would have flowed, we know where it would have carried out the erosion, and we are able to guess the area where the flow would have happened. Let's suppose in a time period of 5 to 10 million years later, in that time duration, there has been a lot of sedimentation which has carried out on top of this. after a lot of sedimentation. Now these sedimentary deposits, they can get converted into sedimentary rocks, right? So let's suppose on this same igneous rock, we have the sedimentary deposits which have happened. So here, what was the earlier shape? The earlier shape was something of this order. The earlier shape was of this order. Now let us assume that on top of that, you have huge amount of sedimentary deposits which have been carried out over a period of time. And these sedimentary deposits, let's say, they have formed a newer kind of a slope. Because the depth of the sedimentary deposits, that is going to vary in different regions. So let's say these sedimentary deposits have happened, and these sedimentary deposits, they have observed or they have followed a kind of a distinct slope. Now if I ask you that out of the two places, if you consider, let's say here, point 1, and let's say if the river were to originate now, if the river were to originate now, where would it flow? At point 1 or point 2? Normally, where do you think the river would flow? Point 2, right? It is in the second portion where the river would have a flow, because that is a depressed area, isn't it? Now, this is what brings us to the characteristic. Now, after the sedimentation has happened, we can say that the profile of the land has changed. We can always say that the profile of the land has significantly changed. So, sedimentation has changed the topographical feature or profile of the land, isn't it? It has changed the topographical profile of the land. Now, due to this, the river is moving in an area where earlier it would not have flowed. So now when the river originates in that area, as a river originates, it will flow as per the profile of the rocks on top, regardless of the flow or regardless of the slope of the base rock. This is the base rock. The base rock is the igneous rock in this case. It is the igneous rock in this case. On top of that, we have the sedimentary rock. Now, let's say a river has originated in this changed condition. And if the river has originated, river will automatically end up flowing in this particular portion. Now, as the river is flowing in this area, it will start eroding materials here, isn't it? It will start carrying out some or the other amount of erosion in this area. And this will continue to happen. It will erode materials even here. The crest region or the anticline region of the igneous rocks would be eroded. If the river would have originated at this stage, it would never have managed to erode the anticline of the igneous rock. But because the river has originated many, many million years later, it will erode the base rock even where the base rock is elevated. Means what? It appears to defy the slope of the base rock. So that is why superimposed. It appears that the river has been superimposed on that base rock. So that is where, observe, this is the kind of the normal base rock. If here you have sedimentation which has happened, now the river will carry out its process of erosion. Regardless of the shape of the base rock, it will erode even the uprised portion of the base rock, just because of the fact that it is draining through that area depending upon the modified slope. So that is the superimposed. Now let us take a look at the definition. So when a river is flowing over a softer rock stratum, right? It will depend upon the slope profile of the softer rock stratum. When it reaches the hard basal rocks, in that case the igneous rocks, but continues to follow the initial slope that it had developed here, it continues to flow along. It seems to have no relation with the harder rock bed. Regardless of the fact whether the rock bed is raised or is depressed, it will continue to flow in that region. This type of drainage is called superimposed drainage. Okay, the stream has enough erosive power that it cuts its way through any kind of bedrock, maintaining the former drainage pattern. So this is a drainage which develops after the land has modified itself, and where, regardless of the slope of the base rock, there will be a continuous form of erosion or degradation happening. That is what is regarded as superimposed. Now, if I ask you a question that where do you find these kinds of drainages that is superimposed? Will you find it in newly created landmass, or will you find these to be prevalent in very old land masses? What do you think? Will you find it to be present in newly created land masses or older land masses? Correct. All of you are correct in this case, except a couple of you. So here, the land obviously will be very old because the land has undergone multiple different modifications, sedimentations, etc. So generally observed over very old land masses. Observed over very old land masses which have underwent multiple stages of evolution, sedimentation, etc. Okay, so that is what is regarded as the superimposed drainage. In India, you find these where? In the plateau region, especially around the region of Chota Nagpur plateau, you will find a lot of these. So in India, example, Chota Nagpur plateau. Okay, we may say that such rivers will be less erosive than rivers flowing in newer landforms. Not always. That will depend on what is the eventual slope, right? So that is something that UPSC doesn't want you to study for your general studies. That is the cycle of erosion and the cycle of degradation of the land. So basically, understand that it always depends upon what is the eventual slope. Many of the times, the land can get uplifted all of a sudden. So that means the river which is cutting through will gain a kind of a rejuvenation will be observed. It will suddenly gain the speed. And when it gains the speed, it will have more erosive power. So it depends on the local geomorphological characteristic. Okay. And Anshu, are these found in Western Deccan Plateau region? Not so much, no. Western Deccan Plateau region, if you think about, or if you are thinking about the logic in that aspect, that you have had multiple depositions of igneous rock upon them. So understand that in the Deccan traps, you have multiple different layers of volcanic rocks, and they have trapped water in between, and does not mean that a river will have enough erosive power to cut through all these deposits of igneous rock. It is generally observed when you have a sedimentary rock and an igneous rock. So soft and hard rock, that is where it will be observed. Roshan, my dear friend, it is a proper noun. If you attach here two H's, that will also be correct. If you attach 5H after in Chota Nagpur, that is also correct. If you attach one H, it will also be correct. Very basics of English and communicative English. When you have a proper noun, you can always play with the spelling of it. There are larger issues to get concerned about, I am sure. An H in Chota Nagpur is not going to concern you that much. Is there any chance that a river completely changes its drainage system? The river can change its flow. The river can always change its flow. For example, take the case of River Teesta. Now, till the 1700s, River Teesta would end up draining into River Ganga, meeting with River Ganga. Now, due to the changes in terms of the deposits which have happened over a period of time, now observe where River Teesta is moving. It meets with River Brahmaputra. So it can happen, what is also referred to as stream capture or river capture. So that also comes into existence. Yes. Okay. But it is not observed, or it is generally, you will not observe that a river which is flowing like this, after some modification, the river has changed its course. In the case of the Indo-Brahm rivers, there is this kind of a concept. Now, as many different concepts, I tell you, I'm always afraid that whether you will mix and match them. But nonetheless, there is this concept where all these Indo-Brahm rivers would accumulate their waters. And we have talked about this, that eventually when you had the subsidence of land in the region of Malda Gap, that provided an exit for all the accumulated water into Bay of Bengal. So if that would not have happened, basically River Ganga would never have drained into the region of Arabian Sea. Right. So oftentimes the modification of land provides a modification to the drainage system in the nearby accompanying region as well. Okay. So now we come to the portion of the drainage pattern. Anand, consequent and subsequent streams have only age difference. There also a lot of conflict is there. Many of the geographers, as I told you, they have a firm belief, and in various research papers also, they have basically published this fact that when you have a subsequent river, it very well might have originated at the same time as the main river or consequent river would have originated. So there also you have a kind of a conflict. So the only difference is that subsequent will end up meeting with the consequent river. That is one of the major differences that you can think about. Okay. Now, after that, we come to the drainage patterns, the main types of, or the major type of drainage patterns in general. So what do we understand by drainage pattern? So whenever we think about a pattern, it indicates a kind of a geographical shape, geometrical shape rather. So the different rivers which end up draining through different areas, they will observe a kind of a geometrical shape, a geometrical pattern. That is the drainage pattern. Now, this drainage pattern is dependent on multiple factors, is dependent upon nature of the rocks, amount of flow, okay, source, point of origin, general slope of the land. Now, this is something which is relevant for your prelims primarily. Now, here when we talk or take a look about the or at the drainage patterns, more or less, it will end up representing a kind of the geometrical pattern indicated. So observe here in the image itself, you will be able to observe that there are multiple shapes. So here, for example, if you will observe, a river is moving and is moving through any kind of random shapes here. Any amount of random shapes, they are being followed. Right? Very much resembling the root of a tree. Sometimes here you will observe that if this is the river flow, let's suppose. Let's suppose. Now here you will observe that the tributaries, they end up joining almost parallel to each other. Why? Because that is where you have the availability of softer rocks. So in areas where you have alternate arrangement of hard and soft rocks, the soft rocks will be eroded, whereas the hard rocks won't be eroded. So that is where you have a different drainage pattern. For example, if you have a central volcanic peak or a central peak and rivers originate from here, they drain into different directions. That is what? A different drainage pattern. So all these indicate a different geometrical pattern depending upon the flow that they will initiate owing to the local topography. Okay, that is what is a drainage pattern. Now, if I ask you the question, can one river exhibit multiple drainage patterns during its flow? Yes or no? Can the same river end up exhibiting multiple drainage pattern during its flow? Yes or no? Very good. So, a same river can end up indicating multiple different drainage patterns because it will move through different areas, different terrains, different territories. So it can always end up exhibiting a variety of drainage patterns. So here, let us take a look at few of the drainage patterns, starting with the dendritic pattern. So when we talk about dendritic pattern, it is here where you will find the flow of the river in any which way as possible. So, for example, let's suppose a river is flowing like this. Let's suppose. Now, here you have the primary tributary, the main tributary. Here you have the secondary tributary, the tertiary tributary, secondary tributary, tertiary, all of them. Now, these tributaries or the river flow also, they are not following any kind of a fixed shape. Whatever would be the slope, they are simply following that. So this resembles the slope of the, or this resembles basically the structure of the root of a plant. So this is what is a dendritic pattern, right? Now, dendritic pattern will be observed in those areas where the rock bed is uniform. That is, it can be eroded everywhere or anywhere at the same rate. So this is generally observed where we have observed in areas of uniform rock bed so that the erosion so that erosion can be carried out equally. Observe the image. The image is that of river Brahmaputra and few of its tributaries. So here you will observe along the mountainous areas. Now, here, many of them, they indicate a kind of a flow in direction, right? Not having a particularly fixed shape. So that is basically a dendritic pattern. Indus, Godavari, Mahanadi, even Ganga, Krishna, all of them, at some stage or the other, they will indicate a dendritic pattern. This is very, very common, especially across the sedimentary plains. Wherever you have sedimentary deposits in sedimentary plains, you will observe the dendritic pattern. Then we have the trellis drainage pattern. Trellis drainage pattern is observed where you have the alternate arrangement of hard and soft rocks. So here we have alternate arrangement of hard and soft rocks. Now, how do we get to this stage where we have an alternate arrangement of hard and soft rocks? So if you have to imagine about a situation, let's say, where you have an alternate arrangement of hard and soft rock, that basically indicates a situation where, let's say, you have the region of the hard rock followed by a region of soft rock. Again, a region of the hard rock followed by a region of soft rock. Followed by a region of hard rock, followed by a region of soft rock, followed by a region of hard rock. So in this situation, you will find that the primary tributaries, they are going to be parallel to each other. So if this is the river flow, observe that the primary tributaries, that is the main tributaries, they are parallel to each other. Primary tributaries are parallel. And the secondary tributaries that you have, if suppose this is the primary tributary, the secondary tributary will join the primary one at the right angle. If this is the primary tributary, the secondary tributary will join at right angles. Secondary tributary joins at right angle. Okay. So how is it? So for example, if you have this as the region of hard rock and this as the region of soft rock. So soft rock is much easier to erode. So that is why in this region, all the primary tributaries will be moving through here. But how do we get at this landform? Many of the times it is a result of folding as a process. How? So imagine a larger rock area, a larger portion of a rock. Imagine the larger portion of a rock having multiple layers. having multiple layers, depositions of hard rock, let's say volcanic rocks, followed by sedimentary rocks, followed by a previously occurring volcanic eruption. So in this region, let's suppose here you have the sedimentary deposits, followed by hard rocks, followed by again sedimentary deposit at the base. That is followed by, let's say, another hard rock. Now imagine if this entire process gets bended, then what will it appear to look like? If this entire process or if this entire region gets bended, what will it appear to look like? Let's say it curves from between, it folded. So here it will give you an appearance somewhat like this. If there is a fold, multiple layers of these folds, because you have multiple layers of the rocks. So here, when this region gets folded, basically, what do we have? The hard rocks have been folded. Let's suppose here you have the soft rock also. Now here the soft rock has also been folded. Above that, the hard rock has also been folded. Above that, the soft rock has again been folded. So that is where you get this structure. Okay, so hard rock and soft rock, both of them will get folded. Now, if suppose there is erosion and degradation and weathering, we have already taken a look at the fact in geomorphology that basically the exogenic forces are referred to as what? Levelers. They are the leveling forces. So here, let's suppose there is a leveling force, exogenetic force, which is in action. So exogenetic force, let's suppose, flattens this area. So what do you have as a consequence? As a consequence, you have a rock layer or you have a land where you will find alternate presence of hard rock and soft rock. Alternate presence of hard rock and soft rock. So that is how we come across this kind of a land surface where eventually it gets folded and then gets weathered down. So that is basically where you will observe the trellis drainage pattern. So again, will it be observed in an older landmass or do you think it will be observed in a newer landmass? What do you think? Will it be observed in an older landmass or newer? Very good. In the older landmass. So typically in all the old land masses, you will come across few of these. So for example, it develops when sedimentary rocks have been folded or tilted and then eroded to varying degrees depending upon the strength. That is, they have been flattened or weathered or eroded. Primary tributaries of the river, they flow parallel to each other, and secondary tributaries, they join them at right angles. So in the small drainage systems that exist across the region, such as Chota Nagpur Plateau, you will come across this kind of drainage pattern. Okay? Then we have the radial drainage pattern. Radial means what? The river originates from a central high point and then eventually it ends up moving into different directions. So from the central high point is where the river will appear to originate. And generally it is observed across volcanic peaks, the older volcanic peaks, not the newer or the active ones, the very old ones. So let's suppose you have a kind of a mountainous area. Now it might happen that from the same river, from the same region of the mountain, you have a river which originates, moves in this direction, you have another river which ends up originating, and it moves in a different direction altogether. So this is where from the same river, from the same upland, it originates and moves in different directions altogether. That is the case of radial drainage. Example, in central India, you have the region of Amarkantak uplands, the Amarkantak hills. Now from there, you have the origin of river Narmada as well as river Son from very close vicinities. Now while Son ends up moving northwards and joins river Ganga, Narmada ends up draining to the west and meets with the Arabian Sea. So that is an example of the radial drainage pattern. So basically here the streams radiate outwards from a central high point. Example is old volcanoes. Good example is in the case of the Amarkantak region, you have Narmada and Son. Narmada and Son. Both of them originate from the Amarkantak region. Son moves northwards, joins river Ganga. Narmada drains westward and joins the Arabian Sea. Okay? Now, after this, we have the opposite of this radial drainage pattern. What is the opposite of radial drainage pattern? Where in radial drainage pattern, what is it? That from the same point it originates and moves in different direction. The opposite of it will be that it originates from different areas and comes and meets at the same point. So this is what is the centripetal drainage system. So this is generally observed in mountainous areas where you have small seasonal streams which are in existence. So if an area is surrounded by hills and mountains from all sides, you have small streams which will end up draining. And those small streams will end up accumulating in the central depression or a large lake. So that is a centripetal, inward drainage, right? So it is similar to the radial drainage system with the exception that here the streams flow inwards. So generally you will observe in the mountainous areas, in the hilly areas, this kind of drainage. For example, when you consider the region of Loktak Lake, you would have studied Loktak Lake in the portion of environment ecology, or whenever you will study environment ecology, you'll come across the Loktak Lake as well. Now, in those conditions, in those regions, you have many small streams end up draining into the central pool. That is basically the ideal case of centripetal. Okay. And here the rivers won't be very large. Here you will generally have smaller rivers. Because imagine if Ganga and Brahmaputra, they will end up draining their entire water in the central pool. Imagine the volume of water which will be there. Everything will get overflooded. So here generally you will observe, generally the existence of smaller streams or seasonal rivers. Okay, that is basically the centripetal drainage. Okay, then we have the pinnate. Now, pinnate drainage system is observed. Let's suppose where we have in the case of Vindhyas and Satpura, let's suppose when we talk about the Vindhyas and Satpuras, these are the block mountains, and in between them you have the Rift Valley through which river Narmada ends up draining. Both of them are block mountains. It is here that river Narmada ends up draining through. Now, any stream which will originate from here will end up joining river Narmada. But these will not be very large streams. These will be smaller streams. So when you have a condition, wherever you have a flow of a river, let's suppose wherever you have a flow of a river, and you have the streams joining them from an altitude at small degrees which are made, they end up joining them at small degrees which are made. That resembles the leaf of a tree. Because when we talk about a leaf, how is that? The shape of it. So when you think about the leaf, this is what a leaf generally looks like. Right? So here, the same feature is observed, and that is what is a pinnate drainage. So as the river Narmada moves in the Rift Valley between Vindhyas and Satpuras, it indicates a pinnate drainage. Is that understood? Or do we have any doubts in this? Good. Roshan, what is shopped rock? There is nothing as shopped. Okay, are you asking about soft rock? Okay. Am I sounding, when I say soft rock, am I sounding like a shopped rock? So basically, a soft rock is where it is eroded easily. So for example, let's say you have a sedimentary rock that is very easy to be eroded, right? It is easy to break the sedimentary rock. That is a softer rock. Okay, that is what is regarded as a soft rock. And when you have rocks, let's say like metamorphic or igneous, they are very hard. It is very difficult to break them or erode them. Those are your hard rocks. Is that understood, Roshan? Anshu, formation of Karevas won't exactly come into the category of centripetal, because here in the case of Karevas, you had origin of these streams and rivers happening from one side, northern portion, that is a Zaskar and the region of the Great Himalayas, and from north it would drain to the south, accumulate in front of Pir Panjal. It was not the case that from Pir Panjal also it was accumulating in the region of Kareva. So not a perfect example. Radial drainage system, when we talk about Sai, radial drainage is from one central peak. Let's say you have multiple streams which originate, all of them they take different directionality of flow. So for example, let's suppose if we have a kind of an existence like this of a mountain or a hill. Now, it can absolutely be possible that a drainage or a river originates from this part, ends up draining in this direction. It can also happen that the river originates here, ends up draining in this different direction. So, from the same mountain, two rivers are originating, both of them are moving in different direction. That is what is radial. Okay. I hope that is understood. So now we'll have another break, and we'll be back by 5:30, and that is when we'll carry on with the discussion of river systems of India and the forests of India as well. Last type, pinnate type. Okay, pinnate type is when you have the river coming down from the mountains or an uphill area for a river which is moving across the depressed, let's say a rift valley. You have small streams which end up originating from the elevated areas. They will join them at smaller angles. They end up joining them at smaller angles. So here, these are your tributaries. All these are your tributaries to the main river. They are originating from a height somewhere in the nearby hills. So all of these will be small streams which are joining the river at small angle. That is what is pinnate. So as river Narmada ends up draining in the Rift Valley between the Vindhyas on one side and Satpura on the other, you will have small streams which will originate and which will end up draining into this. So that is pinnate type. Okay. Is that understood, or any doubts prevail? Let me know, Aarti. Sai, have we understood the radial drainage pattern, or is the doubt prevailing? Okay, I guess it is understood. So that is okay. So now we take a break, guys, and we meet again at 5:30. This is the final large break, the snack break. And then we will talk about the river systems of India, what are the issues with regards to flooding of the Himalayan rivers, the shifting of the river courses, why you have so very devastating floods caused in the Himalayan region, all of that, and also the forest resources, the forest survey resource, everything we shall be talking about. So let's take a break and we'll meet again at 5:30. Okay.